So in chapter 4, we are going to be talking about powers and exponents. We're going to be working a lot with exponents in this chapter. So our first section is going to be introducing them. So if we take a look at our notes here, we have an expression like 5 times 5 times 5 with equal factors can be written using an exponent. So an exponent tells how many times a number is used as a factor. A number that is expressed using an exponent is called, move the wrong path, there, a power, and then the number that is multiplied is called the base. So 5 times 5 times 5 equals the power of 5 to the third. So, a lot of words there. We break it down over here. Our 5, that's a number that will be repeated, is called the base. The 3 then, I think we already know, is our exponent. Then this whole thing together, our 5 to the third, is called a power. So we want to do a little practice with rewriting. So write each expression using exponents. In our first example, we have negative 8 times negative 8 times negative 8. Now notice, the negative is in parentheses each time. So we need to keep our parentheses when we rewrite it. So negative 8 in parentheses, I have 1, 2, 3 of them. So it is negative 8 to the third. In our second example, k plus 2 times k plus 2 times k plus 2 times k plus 2. So this time we have a quantity that is being repeated 4 times. So our quantity of k plus 2 is being raised to the 4th power. And then our last one, 5 times r times r times s times s times s times s. Well, they only have one 5. Your number should always come at the beginning. And then I have 1, 2 r's, so r to the second. And then 1, 2, 3, 4 s's, so s to the 4th. So 5 times r squared times s to the 4th, all being multiplied together. And so there's a couple examples of rewriting with exponents. Now we want to do a little bit of evaluating. So evaluate each expression if a equals 5, b equals negative 2, and c equals 3/4. So our first one, we hopefully know by now that our first step is always to show our substitution. So 10 plus negative 2 to the second. Now notice, when we substitute in with our exponents, you always put the number in parentheses. So 10 plus negative 2 times negative 2, a negative and a negative makes it positive. 2 times 2 is 4, so 10 plus 4, which then gives us 14. Now, this must be in parentheses because if the negative was outside of parentheses, then that would mean that we are only squaring our 2, so it would actually be a negative 4. So please watch your parentheses. All right, second one, the quantity of a plus b all raised to the third. So substitution first. 5 plus negative 2 inside parentheses, all raised to the third. So according to our order of operations, we know that we take care of inside parentheses first. 5 plus negative 2, same as 5 minus 2. So we have 3 positive to the third. And then 3 times 3 is 9. And 9 times 3 is 27. So final answer of 27. And last one like this. 2 minus 3/4 raised to the second power. I can't do anything with this 2 minus first. I need to take care of my exponents. So 2 minus, when I square a fraction, I'm going to square my numerator and my denominator. So 3 squared is 9 over 4 squared is 16. I need common denominators. So my 2 over 1, multiply that by 16, and 16 would become 32 over 16 minus 9 over 16. We're going to run out a little bit of room here. So that 32 minus 9 gives us 23 over 16. for a final answer of 1 7/16. We like those mixed numbers. All right, next up, same idea. What is the value of the expression 6 times a to the third minus 1/9 b to the fourth? So substitution first, if a equals -2 and b equals 3. So 6 times -2 to the third minus 1/9 times 3 to the fourth. Okay, I know I need to take care of exponents before I can take care of multiplication following that PEMDAS. So 6 times -2 times -2 is a positive 4. Positive 4 times -2 gives us a -8, so watching our signs there. Minus 1/9 times 3 times 3 is 9. 9 times 3 is 27, and then 27 times 3 is 81. So just off to the side here. 3 times 3 times 3 times 3. Another way you could have thought of it was 3 and 3 gives us 9 times 3 and 3 is 9. And then 9 times 9 is 81. You could have done the same thing with this if you want to do your side work. So then 6 times -8 is a -48 minus 1/9 times 81. Put your denominator 1 in there if you need to. Gives us 9. And then -48 minus 9 is a -57. Okay, then over here in this little watch out box, please pay attention to this. This is what I was talking about with your parentheses earlier, where -3 to the second inside parentheses is not the same as outside parentheses. In this case, I have -3 times -3, which is a positive 9. Down here, that would be the same thing as -1 times 3 squared. So 3 squared is 9, times -1 would give us a -9. So pay attention to your parentheses. We will give you questions like that. Okay, so comparing 2 to the 5th compared to 5 squared. Well, I know 5 squared, 5 times 5 is 25. Then 2 to the 5th, so 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, so 2 to the 5th is 32. Just multiplying 2 times 2 times 2 times 2 times 2 since it's to the 5th. So 32 is greater than 25. Then 3 to the 6th versus 6 to the 3rd. I'm not sure what 3 to the 6th is, so if I go to my calculator, we would do 3. Then this caret key, that's our exponent, so 3 to the 6th, and hit enter, is 729. Compared to 6 to the 3rd, again, just a little bit of practice. So our 6, our caret key with a 3 is 216. So notice, even though they are the same numbers, not the same order, so they're not equal. Got another greater than. And then -6 to the 4th compared to 6 to the 4th. Well, if I pop over here, oops. Make sure you use parentheses. So inside -6, close parentheses, caret key to the 4th, 1,296. And then we were comparing that to 6 to the 4th. Notice this time we get the same answer, so 1,296. Copy that over here. So they are equal. And then the last one, -4 to the 6th compared to -4 to the 7th. Again, using parentheses. So inside parentheses, -4, close parentheses to the 6th, gives us a positive 4,096 versus negative 4 to the 7th gives us a negative 16,384. Notice on this one we had an odd amount of negatives. So our final answer is negative. So our even, we got another greater than. Okay, now down here, we're going to use the pattern below to describe the value of 5 to the 0. If you notice, 5 to the 4th, 625, 5 to the 3rd is 125, 5 squared is 25, and 5 to the 1st is 5. Each time, to go from one to the next, we're taking 1 5 away. So you could think of it as dividing by 5 each time. 625 divided by 5 is 125, divided by 5 is 25, divided by 5 is 5. So 5 divided by 5 tells us that 5 to the 0 is 1. So anything to the 0 power equals 1. Anything to the 0 power equals 1. Okay, so we have a couple problems for you to try now. I have 2 of them here that I want you to rewrite. So think about what we did on that first slide. And then 2 of them that you should evaluate. Make sure you show your substitution, show all your steps. I want more than just answers when we check your work on Monday.